In Chapter 13, we're going to be looking at probability theory. And in Section 13.1, we're going to be looking at the basics. So random phenomena are occurrences that vary from case to case. In other words, there's a situation where the outcome is determined randomly. We don't know what the result's going to be, so that's why it's called random. A probability is a number that measures the likelihood of a random phenomenon. And that's what we're going to be studying. So we have a number that's going to measure the likelihood of a random phenomena. A probability experiment is any observation of a random phenomenon. The different possible results of the experiment are the outcomes, and the set of all possible outcomes for an experiment is called the sample space. So this is where we're going to start. So in order to be able to determine a probability, we're going to have to know what the possible outcomes are. And in order to do that, we need to determine all of the possible outcomes. And so that is again called the sample space. So this is similar to what we did when we were looking at counting techniques. Example 1. Determine the sample space for each experiment. And so we have two parts here. So part A, we want to know the birth order of 3 children with respect to gender. So if 3 children are to be born, and if each child can only be male or female, then what are the possibilities for the birth order? Well, we can do this like with the tree diagram, again, similar to the way we did this when we were doing counting techniques. So if we think about the first child could be male or the first child could be female. And then if we think about the second child, well, if the first child's male, the second child could be male or the second child could be female. If the first child's female, then the second child could be male or the second child could be female. And then when we think about the third child could be male or female for each of these situations. So if we're here with male, male, the third child could be male or the third child could be female. Male, female, the third child could be male or the third child could be female. If we have female, male, the third child could be male or the third child could be female. And female, female, the third child could be male or the third child could be female. So again, here we're looking at this through the spectrum of a tree diagram. And so this allows us to look at all the possibilities. So following the tree branches, we could have male, male, male. That's one possibility. Or we could have male, male, female. Or we could have male, female, male. We could have male, female, female. We could have female, male, male. Female, male, female. Female, female, male. And last but not least, female, female, female. Now we do write a sample space as a set. I shouldn't have a comma there. I should have it here. So again, we could have male, 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 female, male, female, male, male, female, 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 male, male, female, male, female, 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 male, female, female, female. So these are the 8 possibilities, the 8 possible outcomes when we look at the gender of 3 children and we think about the order that the births could be. So this would be the sample space. Now take a look at part B. Here we have a spinner, and so if we spin this spinner twice, the question is, what's the possible outcomes? What's the sample space? Well, again, we can use a tree diagram for this. So if I think about the first spin, for the first spin we have 3 possibilities. We could land on red, we could land on green, or we could land on blue. And then for the second spin, if I land on red on the first spin, on the second spin, I could land on red again, I could land on green, or I could land on blue. If I land on green on the first spin, for the second spin, I could land on red, green, or blue. And if I land on blue on the first spin, on the second spin, I could land on red, green, or blue. So if I think about the different possible outcomes, following the branches, so I could be red, red. So red, red is one outcome. Red, green, red, blue, green, red, green, 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 blue, or blue, red, blue, green, blue, blue. So there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes that are possible. And again, from our counting techniques, we could tell there should be 9 because we're going to have 3 outcomes for the first spin, 3 outcomes from the second spin. So 3 times 3, there should be 9 outcomes. Likewise, 2 outcomes for the first child, 2 outcomes for the second child, 2 outcomes for the third child. 2 times 2 times 2 is 8. So there were 8 outcomes that were possible. Now, an event is a collection of outcomes of a probability experiment. It is a subset of the sample space. So an event is a collection of outcomes of a probability experiment. It is a subset of the sample space. So example 2, we want to write each event as a subset of the sample space. So question A, so our event is going to be that 2 boys and 1 girl are born to a family. So this is referencing back to question A in example 1. So here was our sample space. This was all of the possible outcomes. And so in question A, we have the event that we get 2 boys and 1 girl. So 2 males and 1 female. Well, this is all males. This is not an outcome that we're looking for here. So here is 2 males and a female. Here's 2 males and a female. That's 1 male and 2 females, so that doesn't work. Here's 2 males and a female. That's 2 females, all females. So our event here, if we have to have 2 males and 1 female, then that could be male, male, female, male, female, male, or female, male, male. So we have those 3 outcomes in this event. So male, male, female, male, female, male, and female, male, male. So these are the 3 outcomes that make up the event getting 2 boys and 1 girl in this family that we were looking at in example 1. Part B, at least 1 red occurs when the spinner from example 1b is spun twice. So at least 1 red. So again, if I go back up and look at the sample space, well, here's at least 1 red, here's at least 1 red, here's at least 1 red, here's at least 1 red. That does not have a red, that does not have a red, that one does have a red, no red, no red. So we have red, 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 green, red, blue, green, red, and blue, red. Those 5 outcomes make up this event. So let's write those down. So this event consists of red, 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 green, red, blue, green, red, and blue, red. So these 5 outcomes make up this event of having at least 1 red when the spinner spun twice. So this is a good place to stop this first video. So we'll stop here and we'll pick up in the next video.